Hi everyone, I'm Madene, and tonight I would like to share my experiences and the lessons that I learned while building a next generation web application. And as Mike said, I will be available for questions, so if you have a question, please, you're welcome to ask me afterwards. Cool, so I am a software engineer at Intellect, and as part of my day-to-day work, I'm mostly involved with the development of web apps. And I particularly enjoy the front-end side of things. And in my free time, I really like mountain biking and traveling, and I enjoy having good food and watching good movies. Okay, enough about me. I'd like to tell you a bit more about the project that I've been working on for almost a year and a half now. And my entire talk is based on my experiences while working on this project. So our client is a chemicals company, and they produce fertilizer on a very large scale, and they sell this fertilizer to some of the most prestigious farmers in the country. And I must say, before starting on this project, I wasn't actually aware of the precise science involved with farming practices. So it's actually a very interesting and unusual domain for a developer to work in. Okay, but in any case, our client has sales representatives. And these sales representatives travel to their customers on their farms. And those farms could be in remote areas with low network coverage. So our client wanted an application that the sales reps could use to create orders for fertilizer while they are at the farmers on their farms, and it could be in a completely offline environment. So the sales reps should be able to use this app on their own devices, which could be a laptop or a mobile phone. But the client also wanted the same application to be available for the back office personnel who would be using this app on desktops. So what we ended up building was an application that can function regardless of the network state and that can be used on multiple platforms and devices. So basically what we were striving for was an innovative new way to create applications for mobile devices. Apps that look and behave exactly like apps on a phone. Just put them on an internet server. They're also easy to update. So you'd think someone said this last year, but in actual fact, it was Steve Jobs that said this at the launch of the iPhone in 2007. And this was how he described how to build apps for the very first iPhone, and it was surprisingly web apps. So little did he know that almost 10 years later, Google would coin this term as progressive web apps. So progressive web app is a website that is built using modern web technologies, but acts and feels like a mobile app. Progressive web apps have various characteristics that make them behave like mobile applications. For example, they are very reliable because they load instantly, even in offline environments. They are very fast, so they respond quickly to user interactions, and they have very nice, smooth animations. You can engage with your users by using features like push notifications. You can even install a progressive web app to your home screen. And when you launch it from there, it loads as a full-screen app-like experience. They fit any screen size, so obviously they are responsive. And they're also safe because they are required to be served over HTTPS. So a lot of these characteristics made progressive web apps a perfect fit for our project. So since you only need a browser to use the application, the app would be available over multiple platforms. So the sales reps could use the application on their phones, and that very same application could be used by the back office personnel on their desktops. Our team was also very familiar with web technology already, and that's why, so we could harness that existing knowledge to build the application. It also makes hiring and training people much easier because you only require one skill set to work on this app. And you don't have to go and learn all the different languages of all the different mobile platforms. The offline capabilities that PWAs offer were also perfect for us because we could then build an app that the reps could use on farms with low network coverage. Since we'd only be building a single web app, we'd have a single code base, which makes it just so much easier to maintain. I'm sure there are a few of you who have experienced multiple code bases, and you'd know that they are usually plagued with inconsistencies because multiple teams work on them. So a single code base also just gives you so much more consistency. This application is going to be used for many years to come. So that's why we also needed to cater for the possibility of future platforms. So, for example, if the Chrome operating system becomes mainstream one day, then we'll already have support for it. And then lastly, browsers are constantly updating their code or optimizing their code for older devices, which meant that our app's features would be reliable and performant even on older devices as well. So the biggest challenge for us while building this app was the offline capabilities. Offline capabilities aren't really associated with web apps, but the latest advancements in web technology have actually made it possible to develop a web app that can function regardless of the network state. So let's have a look at how we developed a truly offline-first web application. So in order to develop an app that can function in offline environments, you need to store some data on the user's device. So there are two kinds of data that you need to consider: static content and dynamic content. So static content is network resources that your app requires in order to load while the device is offline. So an example here is your app's shell. So that includes the HTML, the JavaScript, the CSS, images, whatever resources your app needs to load. On the other hand, we have dynamic content. So dynamic content causes changes to your website, and it also differs depending on the user's preferences and interests. For example, this could be a list of news articles. So let's first have a look at how you store the static content of your web app. You can do this by using a service worker. So a service worker is a script that your browser runs in the background, separate from your main web page. And it has the ability to intercept network requests and respond to them in different ways. The service worker exposes 3 APIs that also provide your app with some mobile-like functionality. So the first one is the push API. You can use this to send updates to your user via push notifications. For example, a breaking news story. Then, since you can intercept network requests with the service worker, it also gives you very fine-grained control over the caching of your website. You can even pre-cache resources even before the user has accessed them. And then you also have access to the background sync API, which will allow you to send messages to the server even if the app isn't open in the browser. So a service worker can use various strategies to cache your static resources. And we're going to have a look at one of these strategies, the cache and update strategy. So this involves serving content from the cache while updating the cache with the latest version of the resource from the network. So the process starts off with your app requesting a resource from the network. the service worker intercepts this request, and it then forwards that request to the server. So let's say the response is taking a bit too long, so say longer than 400 milliseconds. The service worker then goes and has a look in the cache to see if it maybe has a local copy of that same resource. If it finds a cached version, it then responds to the original request with that cached version. In the background, the server may have responded in the meantime. The service worker then intercepts this response, and it updates the cache with the latest version from the network. So if you use this strategy, a user in an environment with good connection will have the best user experience because they'll always have access to the latest version of the content. However, if you're a sales rep on a farm and you need to create this order, it's okay if you are using an older version of the app. Eventually your app will update, but at least you could get some work done. Cool, so use the service worker to store your static content, but for dynamic content, it's better to use IndexedDB. So IndexedDB is a low-level API for client-side storage. And you can actually store large amounts of data in IndexedDB, including files and blobs. So IndexedDB is asynchronous, meaning you can execute queries on IndexedDB without affecting the performance of your app. It also has indexes, so this means you can perform quick searches on large amounts of data. And then it's also transactional, so data is retrieved and updated in a series of transactions. Okay, so IndexedDB had a lot of characteristics that made it ideal for our project. So since we'd be storing the dynamic data on the device, the app would always have access to that, and we could eliminate our dependency on the network, and therefore the app could function even in offline environments. Due to the user's domain and the amount of data we'd be storing, the indexes in IndexedDB also allowed us to perform searches on this large amount of data, and our app still remained performant. And then lastly, we were integrating with a third-party API. And since IndexedDB uses key value pairs, we could just store the documents that we were receiving from that API as is. We didn't need to go and translate those documents into a relational model. So there is one catch with IndexedDB, however, and that is on the amount of data you can store. So the amount of data you can store depends on the browser in which the app is running. So, for example, in Chrome, you can use up to 6% of free disk space, whereas on Firefox, you can use up to 10% of free disk space. On Safari for mobile, the maximum is 50 megabytes, but on Safari for Mac, it's unlimited. And on Edge, it depends on the volume size. So the bigger the volume, the more you can store. So one thing to note is that when the browser is reaching its storage limitation, so it's under storage pressure, there is a chance that the browser can automatically delete the stored data. And if you have an offline app, that could be a disaster because the user expects the app to work offline. So what you could do is you could make use of the persistence API. So with the persistence API, you can request permission from the browser to persist the user's data. The browser will then grant this permission under certain conditions, and then it won't actually automatically delete the data. The user will be prompted and be asked which data should be cleared. So this gives the user a much more reliable experience, and it places the control in the hands of the user. Right, so now that we have got the storage limits covered, how did we actually keep all this data in sync and up to date? Well, the answer is WebSockets. So by using WebSockets, we were able to create an offline sync that was quick, and it used the minimum amount of data. So since the WebSocket was always connected, we could quickly send and receive updates that were available both on the server and on the user's devices. We also used a push-based mechanism on the server. So the server pushed all the latest changes to the device, and this also meant that the client didn't have to constantly poll for changes, and we were only sending data that actually changed. So this lowers the amount of data that's being used. We also have real-time interaction between a user's devices. For example, if the sales rep created an order on his phone, within moments he'd be able to see that same order on his laptop. So there is one drawback with this way of syncing, and that is that data can only be synced while the app is open in the browser. If you would like to sync data while the app is closed, you'll have to implement a background sync. So to achieve a background sync, you can use one of two ways. So you can use the service worker. So the service worker has access to the background sync API. So for example, say the sales rep was on the farm and he created an order, but there was no network coverage. He then closes the app, gets into his bakkie, and drives home. And on his way home, somewhere he regains connectivity. What happens then is Chrome's process wakes up the app service worker, and the service worker then can send all the pending updates and changes that were made while the device was offline to the server. Another way to achieve, so something that I should say is the background sync API is only available in Chrome at the moment. So another way that you could achieve a similar effect is by using push notifications. So the server could periodically send push notifications to the device, and then that would also wake up the service worker, and the service worker could then send the updates to the server. So by using one of these two mechanisms, you can always be assured that you have the latest updates and changes on the server. Okay, so now we have all of the data stored locally on the user's device. Only problem is there was a lot of it, which brings us to our next concern, performance. So we needed to come up with all kinds of creative ways to ensure that our app remained performant, regardless of the amount of data that was stored, the device it was running on, or the network state. Cool. So yeah, we made use of web workers. So the backstory for the web workers. So if I mentioned earlier that IndexedDB is asynchronous and that it doesn't block your application when you execute queries on it. But we discovered that Chrome was a very big culprit when it came to degrading performance while executing queries on IndexedDB. Turns out Chrome actually blocks the main user interface thread while performing queries on IndexedDB. So luckily for us, web workers came to our rescue. So web workers are scripts that your browser runs in the background, separate from your main page. And since it's running on a background thread, it allows you to do some work in the background without affecting the performance of your app. So what we ended up doing was executing all of our queries on IndexedDB inside a web worker. and this drastically improved the performance of our application. You can even share web workers across multiple tabs. And what's also really cool is web workers are supported in all of the major browsers. So yeah, that's really nice. So web workers communicate with the main app via messages. So these messages need to be serialized and deserialized. And that's why it's important to keep those messages as small as possible to improve performance. So what we ended up doing was posting each entry that we received from the database separately on a message. However, we were using Angular for our front end, and Angular has this feature called zones. So the Angular zone is basically a boundary between changes happening inside of the Angular app and changes happening in the outside world. For example, user clicks, network requests, and in our case, messages from a web worker. So this boundary is constantly monitored, and whenever an external event crosses this boundary, Angular reevaluates all its bounded variables to determine what should update on the front end. So if you're a web developer, this is very nice because you can fire off a network request, and when the response comes back, the front end just magically updates. But in our case, it was causing a bit of chaos. Because imagine retrieving 2,000 products from IndexedDB. This change detection cycle would run 2,000 times. And our app became extremely slow. So to counteract this, we processed all of our database queries outside of the Angular zone. And then once we had all the results, we manually triggered the Angular zone to run. So yeah, that made a big performance improvement. Right, so now we've got the zone issue sorted, but now we needed to display 2,000 products in a list on the front end. And rendering 2,000 elements in the DOM, it's not really advisable. So that's why we use virtual scrolling. So virtual scrolling is an efficient way for you to display an infinitely growing list of items. So how it works is only a small amount of elements that actually fit into the viewport are rendered. And then as the user scrolls, these elements are just reused. So what makes it efficient is you're only rendering a small amount of elements at a time, regardless of the amount of items in the list. Cool, so now we've got all of the bits and pieces, but let's have a look at how this actually fit together in our architecture. Right, so here you can see an overview of our app's architecture. So firstly, we had dynamic data that we stored in IndexedDB. So we were performing update, create, and delete queries on IndexedDB, but we weren't performing a lot of them, so we executed those directly from the Angular app onto IndexedDB. However, we were reading large amounts of data. Then firstly, we discovered the blocking issue on Chrome, so we moved all of our queries to a web worker. Then we had the issue with the Angular zone, so we decided to execute all of the queries outside of the Angular zone. So we weren't only storing dynamic data, we also needed to store our app's shell so that it could load in offline environments. For that, we used a service worker. So the service worker intercepts all the GET requests, and then it serves a local copy from the cache if the network is taking too long to respond, and it will then update the cache in the background with the latest version from the server. Right, we also needed to keep all of this dynamic data up to date and in sync, And for that, we used a web worker dedicated to the syncing. So the web worker established a WebSocket connection with the server, over which it sent and received all updates that were available. So whenever an update was made in the app, for example, an order was created, the Angular app would notify that sync web worker, and the sync web worker would then retrieve that update from the database and send it to the server via the WebSocket connection. So when you develop a web app, you always need to keep browser support in mind, and especially with PWAs, because PWAs should work for every user regardless of what browser they use. Cool, so let's have a look at service workers. Service workers are actually supported in Chrome, Firefox, Edge, and most recently Safari has also added support for service workers. Background sync, unfortunately, is only supported in Chrome at the moment. However, push notifications are supported in Chrome, Firefox, and Edge. Safari for Mac has their own implementation of push notifications, so you'll have to do a custom implementation there. And unfortunately, Safari for mobile is they don't support push notifications at all, unfortunately. The second version of IndexedDB is supported everywhere except in Edge, but Edge does support the first version, though. And web workers, very nice, supported in all of the major browsers. Right, so that's what the current state of web technology looks like, but let's have a look at what the future may hold. So people are used to looking for apps in app stores, and that is why some of the big companies are actually starting to support progressive web apps in their app stores. So for example, Google, with Chrome 72 for Android, I think it was at the beginning of the year, it came out with a feature called Trusted Web Activity. And this means you can now publish your PWA in the Google Play Store. Apple, on the other hand, have made no official comments about adding support for PWAs in their store. But it looks like they are pledging support for Safari, which is clear through the introduction of service workers. Microsoft will allow manual submission of PWAs to their App Store, and Bing will actually automatically add apps that meet certain criteria. Then you can also package and wrap your PWA as a native app using tools like PWA Builder, and then you can publish that to the App Store. So with all of those companies pledging support for PWAs, they'll also keep on improving their browsers, and there are all kinds of new and exciting APIs available, or coming out in the near future. So one of them is a web authentication API. So this will allow for passwordless authentication, and it could possibly standardize authentication on the web and make it much easier. WebAssembly is a new kind of code that allows you to run languages like C++ on, in a browser. And what we could possibly be seeing in the future is frameworks like Angular using WebAssembly to improve the performance of their frameworks. And there are even machine learning libraries that are built, that can run on WebAssembly. So imagine you can run machine learning algorithms in a browser. Then the Streams API gives you access to content as it is streamed from the server. So you no longer have to wait for the termination signal before you can access the content. So you can access the content as it comes through and react to it. Web share, payment request, web USB, shape detection, those are all new and exciting APIs to look out for in the future. So as progressive web apps gain popularity, they'll also start getting more access to native APIs, which in the past were only reserved for native mobile apps. So for example, the device orientation API. This will give you access to the physical orientation of the device. So I don't know, some of you may have used that stargazing app, which you point to the sky and then you can see the star constellations. So imagine having that app, but on the web. You can also use the vibration API to give your users non-audible feedback. The media capture API grants you access to the device's camera for image capturing. So, for example, capturing your credit card details. And then also a really cool one is the ambient light API. So this gives you access to the light intensity level in the environment, that's measured by the device's light sensor. And you could use this to switch your app between light and dark theme, or if you have some kind of GPS app between day and night. So with all of these new features and advancements in web technology, I'd like to leave you with the following inspiration to always look for new and better ways of doing things. The key is to embrace disruption and change early. Don't react to it decades later. You can't fight innovation. Cool, that's all from me. Thank you.